In this section, we are going to go over fire pumps basics. In this section, we will cover the basics of fire pumps, with more detailed information to be explored later. Fire pumps are covered in greater detail in NFPA 20, while service and inspection guidelines can be found in NFPA 25, Chapter 8. Fire pumps are a crucial part of fire protection systems in buildings. They ensure that water is sufficient to combat fires, especially when the municipal water supply or other sources cannot provide adequate pressure. It's not truly a system on its own, but a way to feed water to the systems. Fire pumps themselves have the pump and the driver. Fire pumps have 3 types of drivers, with 2 of them is fairly common: electric and diesel, and uncommon steam. Electric motors are one of the most common types of fire pump drivers. They are powered by electricity from the building's power supply or a backup generator. Reliability. Electric motors have fewer moving parts, making them more reliable in many cases. Ease of maintenance. Electric motors generally require less maintenance compared to diesel engines. Automatic start. When the system detects a drop in water pressure, the controller automatically activates the electric motor to power the fire pump. Clean operation. There's no fuel or exhaust management involved, making electric motors environmentally friendly and suitable for indoor use. Diesel engines are used as an alternative to electric motors, especially in areas where power outages are a concern. These engines are similar to the ones used in vehicles and are powered by diesel fuel. Independent power source. Diesel engines don't rely on the electrical grid, so they continue to operate even during power outages, providing greater reliability in critical situations. Robustness. Diesel engines are typically designed to operate in harsher environments, making them suitable for outdoor or remote installations. Though less common today, steam turbines were historically used as fire pump drivers, particularly in large industrial facilities or power plants where steam was readily available. The turbine is powered by steam, which is usually generated from a boiler. Independent power. Like diesel engines, steam turbines are independent of the electrical grid. They use steam as their energy source, which is often available in facilities where steam is produced for other processes. Continuous operation. In certain industrial setups, steam is always available, making the steam turbine a continuously ready power source. A bypass is a pipe that allows water to flow from the water supply to the fire protection system, sprinklers or standpipes, without passing through the fire pump. This is usually done to ensure that water can reach the system even if the pump is not running or in maintenance. You can see what side the feed side by a few things is. Easiest is look for the gate valves like this one. Fire pumps shouldn't have a butterfly valve within 50 feet from the suction side of a fire pump. You ever have to shut off the pump, read the directions of the controller to see the shut-off procedures? Majority will be just hold stop button while pull level to off, then slowly let go of stop. Diesel pumps will have a controller that looks almost like the Jockey controller said, O-A-H. A Jockey pump, also known as a pressure maintenance pump, plays an essential role in a fire pump system. It is a small pump that is designed to maintain pressure in the fire protection piping system and prevent the main fire pump from turning on unnecessarily. The primary function of a Jockey pump is to maintain the system pressure at a constant level when there are minor fluctuations in the system. These pressure drops can be caused by small leaks, temperature changes, or valve operations. Instead of allowing the fire pump to start every time there's a slight pressure drop, the Jockey pump takes care of these small adjustments, preventing the main fire pump from cycling on and off frequently. This is an NFPA diaphragm of fire pump layout without a bypass. This is an NFPA diaphragm of fire pump layout with a bypass. Fire pumps have a way to keep themselves cool without burning themselves up. These are a drain to drain water from the packing. This is a water cooling line, keeping the diesel engine cool as it runs. In this image, we can see an air release valve. Circulation relief valves. Each pump is required to have an automatic relief valve listed for the fire pump service installed and set below the shutoff pressure at minimum expected suction pressure. The valve shall be installed on the discharge side of the pump before the discharge check valve. Vent shall provide sufficient flow to prevent the pump from overheating when operating with no discharge. Let us move on to see what you have learned.